We've got an AC circuit here, an RLC circuit, and we're given the RMS voltage and the RMS current. So let's start with that. We know that the RMS current is equal to the RMS voltage divided by the impedance. Let's start by finding the impedance. Right, so Z is equal to the EMF over the current. That's 120 over 0.54 that's given in the problem, so that's 222 ohms. Okay, now in this problem, the impedance is just, well, Z squared is equal to R squared plus X sub L squared, because there's no capacitor in the problem. So we get 222 squared is equal to 72 squared. Again, these are all given in the problem. 72 is given as resistance. So that tells us that X sub L is equal to 210. So we set 2 pi FL equal to 210. And when we solve for L, we get the inductance is 0.56 henries. Okay, for part B, that was part A, the maximum value of the voltage drop across the resistor. Well, let's find Imax first. That'll be helpful. That's the square root of 2 times the RMS current, so that's 0.764 amps. And now the max voltage across the resistor is just equal to the max current times the resistance. Okay, so if I take 0.764 and I multiply it by 72, I get 55 volts. Part C, the max value of the voltage drop across the inductor, well, that's going to equal the max current times the inductive reactance. So that's 0.764, and then we've got this up here is 210. So that's 160 volts. Alright, now the last part says when I equals 0, what's happening? So let's think about that. When I equals 0, at that time, the rate of change of the current is maximized, right? Because if we look at the graph of current versus time, you know, it's sinusoidal, right? So whenever we're passing through the 0 point, that's when our slope is maximized. So that's when the inductor is going to be maximized. So anyway, the voltage drop across the resistor is equal to 0 since it is in phase with the current. Okay, the voltage drop across the resistor always just directly and easily depends on the current. Whatever the current is at that moment, you just multiply it by the resistance at that moment. Well, it doesn't change. You just multiply by the resistance and that tells you the voltage drop. Now, delta VL at that time is equal to 160 volts. Why is that? Well, because as I said, delta I over delta T is maximized. And so the voltage drop across the inductor must be maximized. We say that the inductor is 90 degrees out of phase with the current. Okay, so when the current is 0, the inductor is at one of these maximum values in its graph. Finally, to get the voltage drop across the power source, we use the loop rule, right? Now, the loop rule doesn't work as an average, right? So in other words, I can't say, like when I say the voltage drop across the power source is equal to the voltage drop across the resistor plus the voltage drop across the inductor, I can't use these two terms because these occur at different times. But these occur at the same time, right? They're both occurring when I equals 0. So I can say that at that moment the voltage drop across the resistor is 160 volts.